Oumuamua is back for us, and it's not stopping. Oh, you remember Oumuamua, the object with the unusual orbit that caused quite a stir when it was first seen in late 2017? All horrifying evidence suggests that it originated somewhere out there in the emptiness between the stars or interstellar space. Now scientists have expressed alarm about the object's potential impact on Earth due to its terrifying nature and movement, with some theories suggesting it could be an alien battle spacecraft. Are aliens trying to spy on us? Could Oumuamua be an extraterrestrial comet preparing to destroy humanity, or a spacecraft destined to conquer us? Join us as we explore how Oumuamua isn't stopping and its incoming impact. What image or idea does the term alien probes evoke for you? Perhaps it's reminiscent of 1960s abduction tales, where extraterrestrial surgeons use surgical instruments to probe and prod human subjects. On the other hand, maybe you see something more like Oumuamua, a cigar-shaped interstellar interloper that slingshots around the center of our solar system roughly 15 million miles from Earth. Back in 2017, the second category of possible probes is what scientists, including ABYLB of Harvard University, are interested in. YLB, who has a doctorate in plasma physics, has probed the ocean floor for signs of extraterrestrial visitation and has speculated that Oumuamua could have been a spacecraft from another planet. Earth scientists have sent space probes like Voyager and New Horizons into space. So in theory, these might be the same type of probes. Space probes, whether they originate from another planet or our own, are essentially scientific devices launched into space to gather data about space and other planets. However, Earth scientists lack the expertise necessary to send a probe into space and return to Earth. That is why astronomers and physicists are working around the clock to figure out how extraterrestrial spacecraft could possibly navigate interstellar space to contact Earth, and how we could perhaps intercept their messages once they do. Two big obstacles would stand in the way of an extraterrestrial civilization's desire to send a probe to Earth: distance and time. As an illustration, extraterrestrial probes would have a 2.5 million light-year journey ahead of them if they were dispatched from the Andromeda Galaxy, our closest galactic neighbor. This would be a vast and extraordinarily lengthy journey, as 1 light-year is equal to 6 trillion miles. If the extraterrestrials wanted to return their probe to Earth before their civilization collapsed, they would have to figure out a way to travel at speeds greater than light. Is it possible that extraterrestrials have figured out how to use theoretical wormholes, warp drive technology, or other technologies that we are unaware of? By discovering new laws of physics, there might be other challenges for extraterrestrials to overcome. Even if they manage to decipher the code for the galactic speed restriction on their lengthy voyage to Earth, extraterrestrial engineers would have to construct probes that can endure the weathering effects of space radiation and space debris. Creating novel materials with enhanced hardness and material toughness would be necessary for this. In general, a material's toughness is defined as its energy absorption capacity. Naturally hard materials such as diamonds are often not very tough. A material with high fracture toughness and high hardness, the ability to resist deformation, will be ideal for use in impact resistance. Do you not find Oumuamua to be really formidable? In the fall of 2017, the tiny object named 1I/Oumuamua traveled through the inner solar system, passing close to the Sun. As it did so, the fact that it was the first known object to have originated from a solar system other than our own gave it historical significance. Astronomers designated it 1I/Oumuamua, with the 1I referring to it being the first interstellar object discovered in our solar system, though the name is now commonly shortened to Oumuamua. For quite some time, astronomers had been anticipating the arrival of an interstellar object similar to Oumuamua. After decades of speculation, NASA's Associate Administrator for Science at the time of Oumuamua's discovery, Thomas Zurbuchen, stated in 2017 that they now had direct evidence that such interstellar objects exist. A second solar system interstellar object, 2I/Borisov, was discovered in August 2019. On the other hand, Borisov appeared to be a typical comet, complete with a tail and coma, the gaseous head surrounding an icy core. When compared, Oumuamua stood out due to its remarkable lack of a tail and coma. Predictions of the existence of interstellar objects predate the discovery of Oumuamua, but Oumuamua wasn't what the astronomers had hoped for. The tiny, oddly shaped object didn't resemble a comet, but it seemed to be outgassing as it went. The most prominent hypotheses center on the sublimation of hydrogen ice or nitrogen ice from other solar systems. Interstellar objects are propelled into space by the gravitational pull of gas giant planets or by massive collisions that tear protoplanets apart. Being the first known interstellar visitor, Oumuamua sheds light on the nature of other planetary systems outside of our solar system. The form of Oumuamua was likewise remarkable. At first glance, the object appeared to be 10 times longer than it was wide, giving it the appearance of a large cylinder. The original measurements were 6.6:1, but astronomers eventually adjusted them to more accurately depict a pancake form. The minor planet Arrokoth, which the NASA New Horizons probe passed by on New Year's Day 2019, is one of several similarly shaped objects that astronomers have observed in the Kuiper belt beyond Neptune. The light curve, a graph that follows the object's brightness as it fell through space, was used to determine the dimensions and shape of Oumuamua. When we saw the wider side of Oumuamua, it seemed brighter. The exact stellar system from which Oumuamua came is a mystery to all. Nevertheless, in 2018, researchers traced Oumuamua's return to its original route toward the Sun and discovered that 1 million years ago, the object passed close to 4 stars, with the red dwarf star HIP 3757 being its closest contact. It is possible that Oumuamua originated there or that it has been lost in space for a very long period of time. The solar system's planetary bodies, asteroids, and comets all follow tight orbits around the Sun. A NASA animation explains that Oumuamua's trajectory was hyperbolic, meaning that it approached the Sun at such a high speed that its route could only be minimally bent by the Sun's gravity, rather than being captured in a looping circle. Oumuamua, which was moving at a relative speed of 16.36% as 23 million miles to our star, wasn't discovered until over a month later on October 19, 2017, when University of Hawaii astronomer Rob Warrick discovered Oumuamua in observations made by the Asteroid Hunting Panoramic Survey Telescope and Rapid Response System, PANSTARRS. At that time, Oumuamua was 21 million miles from Earth, and its trajectory eventually brought it as close as 15 million miles from that point. The extraterrestrial guest has been making its way out of our solar system, with NASA detailing how Oumuamua was propelled to a speed of 54.2 meters per second by a gravity boost from the Sun. The window of opportunity to observe Oumuamua was minimal, lasting only a few weeks due to its small size and rapid motion away from Earth. The Hubble Space Telescope was the instrument that could follow it for the longest period of time. By merging data from 2 of the world's largest optical telescopes, the Very Large Telescope in Chile and the Gemini South Telescope, the finest photos of Oumuamua, like this one, could reveal the star as tiny as a speck. Now well outside of Neptune's orbit, Oumuamua is making its way toward Pegasus. Our telescopes can no longer see it since it is whizzing by the Kuiper belt, a ring of frozen objects close to the solar system's periphery. Could it still come back toward Earth? What if it's an alien probe? What exactly Oumuamua was is a matter of conjecture. When the gravitational waves of roving gas giants wrenched Oumuamua out of her orbit, we know it was an object ejected from a planetary system outside of our solar system. It was believed by astronomers, prior to the discovery of Oumuamua, that interstellar objects like 2I/Borisov would resemble comets. For a long time, astronomers assumed that Oumuamua was just a dead comet, whose volatiles, or gases with low boiling points like water, evaporated over billions of years, either while it was still in its original system or while it was close to other stars, since it didn't produce a cometary tail. On the other hand, Oumuamua's non-gravitational acceleration was detected by the Hubble Space Telescope as it departed from the Sun. Since comets often emit water vapor and dust in a tail, which provides them an additional boost, this is a normal occurrence for comets. There was no indication that Oumuamua was releasing water or any of the other volatile substances that are typically seen on comets. Oumuamua could be either of 2 things according to the most popular theories. Oumuamua is a lump of nitrogen ice, according to one theory put forth by Arizona State University's Alan Jackson and Steve Desch. Oumuamua might be a piece of nitrogen ice that a massive impact blew off of a Pluto-like body, according to Jackson and Desch, who proposed the theory after New Horizons detected regions such as Sputnik Planum that were basically frozen nitrogen lakes in 2015. Oumuamua would have had the additional boost it needed if the nitrogen outgassing had been melted by the sun's heat, because nitrogen gives comets a more reflecting albedo of 0.64. Oumuamua would have had to be smaller than originally anticipated to have seemed so pale, according to the calculations done by Jackson and Desch. The dimensions of Oumuamua would be a mere 148 by 144 by 25 feet if it were constructed from nitrogen ice. Cosmic rays may have reacted with surface ice while Oumuamua was in interstellar space, freeing hydrogen from some water molecules and creating a supply of hydrogen gas trapped in amorphous water ice, according to another theory put forth by Cornell University's Daryl Seligman and Berkeley University's Jennifer Bergner. Seligman and Bergner postulated that while Oumuamua went by the sun, the interstellar object was warmed but not sufficiently to evaporate its water ice. Instead, the hydrogen was able to escape at a rate of 0.4 to 28.0 per, because the heating altered the crystal structure of the ice, which is what gave Oumuamua the apparent push. This would also clarify why Oumuamua didn't appear to have a dust tail. The dust would have remained trapped in the water ice. Astronomers A. and S.E. Chimbiali of Harvard University have proposed a theory that Oumuamua was actually a solar-powered spacecraft based on the non-gravitational acceleration. The numerous peculiarities of that extraterrestrial guest would be satisfactorily explained by an artificial origin. The course that Oumuamua took suggests that it is not local. How big or what shape Oumuamua takes is a mystery, since a detailed photograph of the visitor was not possible. Astronomers must rely on its brightness as well as their understanding of the reflectivity of asteroids and comets to make size estimations. Since astronomers have not yet seen a coma or tail surrounding Oumuamua, and LB does not believe the comet scenario is valid, in addition, outgassing would have altered Oumuamua's rotation period, an effect that would have been easy to identify, LB said. But we haven't seen such a change. He also mentioned another potential natural explanation. The apparent movement could be due to the kick that caused Oumuamua to break free from its parent object. If that is really the case, contrarily, Oumuamua has demonstrated repeated non-gravitational acceleration according to LB. So this kick wouldn't be permanent. As a result, B and LB proposed a novel theory: sunlight could be to blame. The latest analysis found that if Oumuamua is only 0.3 to 0.9 millimeters thick, the observed non-gravitational movement could be caused by solar radiation pressure. How could a structure be so delicately thin? One such option was proposed by B and LB, a light sail that uses the kinetic energy of photons to propel itself. This technology has already been demonstrated in orbit. In 2010, the Japanese Ikaros probe made it to the neighborhood of Venus. In 2011, the NanoSail D2 spacecraft from NASA circled the Earth, and in 2015, the LightSail craft from the Planetary Society did the same. But their primary goal was to test sail deployment. A LightSail Oumuamua could likely survive a long interstellar trip according to B and LB's calculations based on the rates at which the object would encounter these deep space fluxes and the concentration of gas and dust in the interstellar medium. The researchers calculated that Oumuamua could potentially travel at least 16,000 light-years from its home system, whichever that may be. The object's origin is still unknown. It should be noted that B and LB do not assert in this analysis that Oumuamua is undeniably an extraterrestrial spacecraft. Nonetheless, they hold this possibility in high regard. Maybe it's an alien spacecraft that has landed on Earth by accident, or it may be a piece of space trash. According to the study, it could also be an active spacecraft that was sent here to examine our solar system. According to LB, there are arguments in favor of the second theory. For starters, Oumuamua's very discovery was something of an anomaly. If the visitor is a member of a random population stumbling across it the way we did, suggests that every star in the Milky Way ejects into interstellar space 1,000 trillion such objects over its lifetime, LB said. These numbers are based on calculations performed by LB and his colleagues a decade ago. Our own solar system doesn't shed so many Oumuamua-like objects. Furthermore, the kinematic space called the local standard of rest, which includes our region of the Milky Way galaxy, nearly coincides with Oumuamua's motion. That is the reason why the object's system of origin has remained elusive. We will never be able to use conventional chemical rockets to catch up to Oumuamua as it cruises toward the outer solar system. That being said, it is not impossible that we may get a close look at the object. Our ability to send small robotic probes equipped with sails hurtling toward Oumuamua at breakneck speeds could pave the way for a future voyage there. Launching such a vessel in the next few decades is the goal of projects like Breakthrough Starshot. It doesn't matter if we ever catch Oumuamua, but we can learn from its visit and be prepared for the next time anything like these travels through our area. By conducting a full-scale observational blitz, the example provided by Oumuamua should also inspire astronomers to take a harder look at other intriguing objects that are in view right now. What could we do in the event that the Oumuamua space probe returns? Is it time to build a Corellian shipyard? If we're to assume that something extraordinary occurred, which is quite the leap in and of itself, it's worth speculating on what we should do if the asteroid space probe comes around again. In order to construct spacecraft capable of pursuing the probe, humanity must get a deeper comprehension of the nature and manipulation of dark energy in the cosmos. One suggestion is to send a craft after the asteroid probe. The challenge is formidable. Oumuamua has a hyperbolic excess velocity of $5.50 per year. It will be beyond Saturn's orbit within 2 years. This is much faster than any object humanity has ever launched into space. Therefore, what kind of vessel would it have to be? How far from the realm of realistic physical theory does our endeavor extend? Do we board the ship in space, or do we use fuel to leave the gravity of Earth and then get ready to travel through space? Solar sails? A wormhole? The concept of wormholes is fraught with 3 issues. First, they always seem to collapse just before someone tries to pass through them. Second, wormholes link other universes, not just faraway corners of our own. And third, we have no idea how to construct one. In an effort to cultivate a launch pad in the asteroid belt's periphery, as Freeman Dyson had previously suggested, a ride to Allo, to put it another way, an Allo drive would make you feel like you're riding a moving conveyor belt through an airport. A device known as a warp bubble might do this. The warp bubble occurs when the imaginary space behind you on the airport conveyor grows, propelling you ahead, and the imaginary area in front of you decreases, drawing you closer. Space-time is flat within and outside the bubble, but it takes on a curved shape around its periphery, giving the illusion of a squeezed bubble. The fact that a warp bubble needs negative mass is just one of many reasons why nobody knows how to construct a warp engine to propel a spaceship the size of an automobile. You would have to create an object with the mass of Jupiter while the generation of negative mass is happening somewhere in the cosmos. How exactly humans may tap into this untapped potential is still a mystery. Thanks for watching another episode. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.